Problem 6, letter B, is a good example of a problem that we're asked to do it by logarithmic differentiation, and in this case you have to. There's no other options in this problem because we have a variable term in both the base and the exponent of our function. Our function g of x is equal to x to the power of sine x. So we have variables in both. The only way to do this is with logarithmic differentiation. So remember, for logarithmic differentiation, our first step is to take the ln of both sides. So we get ln y equals ln x to the sine of x. When we do that, we can use our log rules on our function over here to bring the power down. So we get sine of x times ln x. And now we're ready to take the derivative because it's going to be much simpler. So the derivative of ln y, y prime over y. And the derivative of sine x times ln x requires product rule because we have two different functions of x. So we're going to get cosine x times ln x plus sine x times the derivative of ln x, which is 1 over x. So that was by using the product rule. And finally, the last thing we can do is just multiply by y and plug in what we know y was, which is x to the sine of x power. So we get that our derivative is x to the sine x power times this entire thing, which can't really be written any simpler. It's just cosine of x times ln of x plus, I suppose for this part you could write sine x over x because you're multiplying sine x times 1 over x. But this is our derivative here, and that's about where you can leave it because there's nothing else you can simplify there. Again, we had to use logarithmic differentiation because you can't use any of your normal differentiation rules when you have a variable both in the base and the exponent.
The Teaching Center, UF's Learning Resource Center.